So we're going to find the focal length for a meniscus concave lens. We're given the two radii of curvature of the two different surfaces. So meniscus means that both sides are curving in the same sense. Concave says that the concave side has the smaller radius of curvature, and so that's going to dominate the behavior. In other words, we would expect a focal length that's negative. We expect that f is going to be less than 0 here. So go ahead and sketch this. Now, the convention is that light always arrives from left heading towards the right. So R1 is going to be the leftmost surface, R2 the rightmost surface. And because both of these are convex to the left, in other words, they're curving such that their centers are rightward, both of these radii will be positive numbers. So a couple of assumptions we need to make. First off, we're assuming that the ray model of light is going to work in this case. That essentially comes down to assuming that the lambda is much, much less than any distances or sizes of anything here. We're also going to assume that that thickness T of the lens right here is much, much less than either radii of curvature. This is going to allow us to treat this as a thin lens. And then finally, we're going to assume that all the rays we're dealing with are paraxial. That essentially comes down to assuming that most of those rays are not coming in at a high angle of incidence, that angle is going to be much, much less than 1. Or when we derive the equation for the refraction of a spherical surface, when you're talking about the height h where the ray hits the lens, that had to be much, much less than any of the distances involved, such as the radii. If this is the case, then we can use the Lensmakers equation to go ahead and solve this. So here are the list of my known and unknown quantities, and because both of these surfaces are convex to the left, they are positive radii of curvature. Here is what I'm trying to find ultimately. And then because of assumption number 3, I can go ahead and use the Lensmakers equation right here and just plug things in. So we're going to go ahead and just do a little bit of algebraic manipulation, and I'm going to try to get f on top. And so what I need to do is get a common denominator for this term here, and then go ahead and combine everything until I have a single fraction on both sides of the equation. Once I have a single fraction, I can then just flip everything over. And so we end up with this as my resultant equation for the focal length. And this is true in general, not just for this problem, but for any problem where you're using the thin lens equation. And by plugging my numbers in, I get negative 40 centimeters. So that negative is important because I was expecting that for a meniscus concave. And then we're not done with the problem. We need to evaluate it and essentially say, why is this answer reasonable? And here's my line of reasoning. I essentially said that the concave surface dominates the behavior. Now, because we have a convex and concave surface, they're kind of working against each other, if you will. So what that says to me is that if we had a similar radii of curvature, but they were either pure convex-convex or concave-concave, in other words, I had either a lens like that or a lens like that, I would expect either of these two to have more focusing power. And I'm putting that in quotes because that's not really a term, but essentially either of these two lenses should be able to focus the light down much quicker, which means that they should have a focal length that's less than negative 40 centimeters. So I'm going to go ahead and assume a convex-convex lens, which means that R1 is positive because it's convex left, but R2 is negative because it's concave left. So plugging that in, I end up getting 13.3 centimeters. In other words, if you have parallel rays of light coming in and hitting that lens, they're going to focus down in a much shorter distance than they would for the other lens, for the meniscus concave. And so that really kind of backs up my my assumption and my guess. And so I feel that this is a reasonable answer because the convex-convex focal length is less than that of my meniscus concave.